morning, everyone. It's a pleasure to be here at the Applied AI Summit. I'm Wang, a research scientist at Google DeepMind and creator of AG2. I want to take you on a journey through where we've been in the past 3 years with Agentic AI, where we are now, and where we believe we're heading. Let's start with a simple vision. Imagine an agent, not just a chatbot, but not just a tool, but a digital companion that learns and evolves with you. This agent collaborates with sub-agents to handle complex tasks. It knows when to step in and when to step back. When I began working on Agentic AI in early 2023, I dreamed of an agent with a natural interface, strong capability, and scalable architecture. That dream motivated the creation of AutoGen, now AG2. And today, we see the industry converging on that Northstar. I'd like to start with reflection on AG2's journey and then discuss the trend on each of these 3 dimensions. Let's talk about AG2 first, the open source agent OS. It provides a solid foundation for researchers and developers working on Agentic AI. AG2 was built around 3 principles: simplicity, capability, and reusability. Simplicity means developers don't have to overthink, just one intuitive abstraction to work with. Capability means you can go beyond toy examples to serious multi-agent workflows. And reusability, avoiding reinventing the wheel, letting people compose powerful patterns quickly. One of my favorite moments was seeing developers orchestrate agents like musicians in the jazz band, each improvising but within structure. The most essential concepts of AG2 can be described with this slide. We want developers to reason about any arbitrary complex applications in simply 2 steps. Step 1 is define agents of different roles, and step 2 is to get them to talk. The agentic abstraction here is very general, but incorporates different backends, such as language model-based backends, human input backends, or non-language model tools. So you can mix these different type of backends in one primitive agent. How do we construct more powerful agents using these primitive agents? All these agents share the same interface, like generate replies, send messages, and receive messages. So we can use that interface to do conversation programming using some provided conversation patterns from AG2, such as sequential chat, nested chat, and group chat. And these building blocks can be used to compose more complex applications, and you can also customize your own conversation patterns. Take a look at this customer service example. The user asks for help, and agents handle authentication, triage, and order management. It contains a customized group chat among agents, covering order triage, authorization, and order management. The workflow context shared by all the agents in the group chat keeps their transition smooth. The order summarizer and order retrieval agents are a good example of a nested chat, where they work together to get the necessary details and summarize them for the order management agent. The nested chat provides hierarchical context management. It's a modular approach to extend the functionality of a single agent using multi-agent architecture recursively. This is AG2 in action, handling real problems with a coordinated effort. I hope this gives you an idea of what's possible and how you may compose a powerful agent using different building blocks of multi-agent architecture. The journey of AG2's growth is a good reflection of this wave of agentic AI. We started with the initial prototype back in March 2023, a flexible multi-agent conversation framework that can run code and functions. A few months later, in August 2023, the research paper was published that helped crystallize the concepts. By October 2023, AutoGen was trending on GitHub, and the developers were picking up fast. We have a large community on Discord, developers actively sharing ideas and building together. In 2024, the work was recognized with the Best Paper Award at iClear's Agents workshop. The users of AG2 have been making new records on challenging benchmarks like OS World, Sweetbench, Web Voyager, etc. Those milestones were not just for AG2, but for agentic AI research more broadly. AG2 is already used in a wide range of real-world applications. We see it in everything from autonomous trading to customer support and software engineering. It's powering agent platforms at Google, business automation, chip design at NVIDIA, and even industries like construction and farming. It's also used by major companies like Walmart for things like marketing and recommendation. Each case reminds me, this is not just a technical shift, it's a platform shift, like the early days of the web or mobile. From cybersecurity to healthcare, no one wants to miss this revolution. So AG2's story really mirrors the industry story, from prototype to paper to community to production. It shows how quickly agentic AI has moved from idea to reality. AG2 has generated far-reaching influence, not only by the open source project itself, but also by the cutting-edge research enabled or inspired by it, the communities fostered, and other projects enabled or inspired by it. I'll share more examples when I discuss each dimension of our Northstar: natural interface, strong capability, and scalable architecture. Dimension 1, interface. Today's AI is gaining sight and sound. Gemini Live can use your camera to see the world during the conversation and speak to you in real time. Some early prototypes can even see your screen and trigger actions by your side as you use your devices. These advances narrow the gap between intent and understanding, but to reach our North Star, the context must flow across devices, and the agents must know when to engage or stand back. Innovation in the interaction interface moves quickly from ideation to product. In September, I saw multiple ideas turned into reality. Agents work while you sleep. Pulse makes agents continuously productive even you are offline. And agents connect to your devices. Orion bridges the gap across platforms and hardware, letting you talk to all your compute and data anytime, anywhere. And agents connecting people. That journey started in 2023, and people are still exploring what that looks like. How do agents mediate, collaborate, and amplify human-to-human interaction? My bet is that we'll see some big moves before this year ends. Dimension 2, capability. Understanding is only half the battle. Agents must act. Coding assistants like Claude Code and Gemini CLI integrate into developer workflows, autonomously writing and refactoring code. The ChatGPT agent blends browsing, execution, and document creation in one workflow. Why this is a big deal? Code is meta power. An agent that can change its own software can self-improve, experimenting, learning, and spawning new sub-agents. To realize this, we need long-term memory, cross-session reflection, and learning by interaction. Dinario is a standout. It's modular automation for scientific research. Check out the GitHub link for details. It uses multi-agent systems to generate ideas, validate them, and even write papers. It's built using AG2, CMB agent, and LangGraph. AG2 has a profound role in this project because CMB agent uses AG2 for data analysis, started from cosmology, but generalized way beyond it. LangGraph is a graph-based multi-agent framework inspired by AG2 since the AutoGen regime. The architecture diagram walks through the process. These modules are agentic systems that can generate the idea for a research project, check the literature to validate the novelty of the idea, develop a plan to carry out the project, implement the plan by writing and executing code, making plots, and describing the results. Write a scientific paper discussing the research, and show the plots, and review the paper. It's a game changer for researchers. Have you explored tools like this? And now this has happened along. This slide highlights our amazing collaborators, scientists from Cambridge, Harvard, Google, and many more institutions across the world. Their diverse expertise fuels our progress and really moves the needle. A big thank you to everyone here. Hundreds of papers have been generated in many science domains: biology, biophysics, biomedical informatics, chemistry, planetary science, mathematical physics, quantum physics, plus cosmology, plus machine learning, medicine, neuroscience, material science. Fun fact, in the New York panel last December, Jerry asked the question when AI is going to be as capable as human scientists. The answers from panelists are 3 to 5 years, 10 years, or never. What is my answer? Next year, which is 2025. It's hard to believe how fast it is, including myself, but I'd rather be prepared and hope to prepare others around me. It's already too hard to keep up with the pace of innovation, and AI accelerated research will make that worse. I'm glad that someone has been working on solving this problem. GetRank, led by Terry Rodriguez from Remix AI, turns research into testable PRs in minutes. It's a practical tool for developers to discover relevant research and integrate into their own repos. This screenshot shows it in action. Terry gave a talk recently at AG2 community, and here are some notes taken from his talk. It solves a very practical problem. No matter how many good papers are out there, they don't add value to you until you're able to integrate the right technique into your app. How do we actually find and validate the right ideas, tools, and code? First, we need better personalization. Imagine recommended papers tailored not just to your field, but to the context of your current app or experiment. And second, filter for what's truly actionable. Papers and repos with runnable code should surface higher because reproducibility is what matters. Third, testable PRs. Too often, the implementation gets stuck in vibe hell, endless synchronized chats that go nowhere. Agents can bypass this by proposing concrete, testable pull requests. Terry found that AG2 gave them the tools they needed to solve testing and build automation challenges, including the teachability feature for AI agents. Agents need to learn over trials, and that's how they get better, not just by memorizing, but by improving with every cycle. On the right, you can see an example pipeline for AI-assisted repo experiments. It starts with app history and interests mapped to relevant papers, both in code from places like Hugging Face or GitHub, spins up reproducible Docker environments, and then hands it off to an agent that tests and repairs automatically. This is how we bridge research with production, turning papers into pipelines, claims into code. At the end of the day, it's not just about faster discovery, it's about accelerating adoption of cutting-edge methods, ensuring reproducibility and validating claims directly against your stack. Dimension 3 architecture. In future, breakthroughs will come from collaboration among diverse agents. AG2 orchestrates multi-agent teams. Mastran, a very new open source project I'll introduce next, pushes further, running agents in parallel, observing and refining each other's work. Imagine scaling recursively. Each new agent amplifies the whole. The potential is exponential, but we must solve consensus, shared memory, and interoperability. These are all challenges in human organizations too. It's fitting that AI faces them now. Traditional scaling laws are running out of room. We've already seen signs. Early GPT-5 training runs were delayed for more than a year. Bigger isn't automatically better anymore. Inference time scaling is a good idea under exploration. Right now, there's no universal way to leverage improvements of foundation models or agents at runtime while avoiding their limitations. We haven't figured it out yet. So what's the way forward? A new paradigm is to scale multi-agent systems. Instead of just pushing model size, we orchestrate agents at inference time and make them coordinate, collaborate, and self-improve. The gains are real and measurable. With a single agent setup, Grok 4 standard reached a 38% score on the last human exam benchmark, the highest when it was announced in July. Now compared to Grok 4 Heavy, a multi-agent collaborative system, the score jumped to 44%, no change to the model, only by multi-agent scaling. It's priced 10 times more expensive than Grok 4 standard, and that's a price for the multi-agent scaling technology. Gemini DeepThink won gold medals at both the International Mathematical Olympiad and the ICPC programming contest. OpenAI did well too. Multi-agent scaling has been used to solve problems at the very frontier of human computation. Mastran explores this new frontier of scaling. It is built on the foundation we've been developing with AG2's research and community, and it's only 2 months old. Think about how humans solve problems together. In a study group, different people bring different strengths. Someone is good at math, another is bringing the big picture. Together, they tackle problems no one could solve alone. Mastran mirrors that dynamic. It bridges different ecosystems. Instead of isolated silos, it's becoming a federation of intelligence. The magic is in the emergence. Collective problem solving produces insights beyond any single agent could do. It's not just additive, it's multiplicative. Agents don't just collaborate once, they learn from each other in real time. Each interaction makes the whole system smarter. Okay, Mastran's architecture. The Mastran orchestrator takes a user query and distributes it to a team of agents. It specifies models, configurations such as tools. Each agent operates in parallel, using its unique capabilities, search, coding, browsing, file systems, MCP servers. The shared collaboration hub is a magic. It's a real-time notification system where agents post summaries of their progress. Others can observe, critique, and refine. We detect convergence when solutions stabilize, using adaptive coordination to restart loops if needed. Here's a real example of how multi-agent collaboration leads to better outcomes than any single agent could achieve. This is a graduate level physics question from the GPQA Diamond benchmark. It's a tough problem, something even advanced models often miss. Look at the first round. None of these initial answers are correct. And here's where collaboration matters. One agent notices a major discrepancy from different agents. Instead of doubling down, it revisits the calculation. That peer observation triggers a self-check. The breakthrough moment is when the agent revises the answer. And eventually, 3 out of 4 agents converge on the correct answer. The system as a whole succeeds where individual agents failed initially. This is the promise of multi-agent reasoning. Not perfection on the first try, but the ability to catch mistakes, correct each other, and converge on truth. That's a fundamentally different kind of intelligence. If you're curious, you can explore any other case studies at case.mastran.ai, and here are a few examples. LLM Fun Facts website. Multiple Cloud Code agents build interactive websites with isolated workspaces. The key result is conflict-free parallel development, something every software team dreams about. Unified file system. This was cross-backend collaboration between Gemini and Cloud Code agents. They co-created educational content, producing a comprehensive 25-slide presentation without human micromanagement. There are examples also like multi-agent fact-checking, where it's impressive that the system reached accuracy despite conflicting information. And that's something humans struggle with too. In finance, agents work together on complex cost calculations. Each of these demos shows an interesting use case. And we're just scratching the surface. There are still many challenges, like I mentioned earlier, regarding consensus, context sharing, and interoperability. And we need your help. Please check it on GitHub and join our Discord to work on this scaling problem together. Let me leave you with this synthesis. Natural interfaces turn intention into understanding. Strong capabilities turn understanding into action and self-improvement. Scalable architectures let many minds co-create the solutions. By weaving these layers, sensory richness, self-modifying code agents, and multi-agent frameworks, we glimpse AI that doesn't just answer questions, but grows with us. Thank you, and I can't wait to hear your thoughts and questions.